Hi, I'm David, and I'm an applications engineer at Solego. In this video, I'm going to give you an overview of our GreenPAK Designer software and show you how to create a simple design. First, you'll need to go to our website at www.solego.com and download the latest version of our free GreenPAK Designer software. Once you have the software downloaded, you'll need to navigate to the Develop tab and then pick a part that you want to use. For this project, I'll use an SLG 46110. When you create a new design in GreenPAK, the software will prompt you to enter voltage and temperature specifications, which help us trim the part for your specific application. For this project, I'll make the minimum voltage 3 volts, the typical 3.3, and maximum 3.6. For temperature, I'll just use our maximum temperature range of -40 degrees, 25, and 85. Here's a look at the timing diagram that we'll be working with during this lesson. In this project, I have 2 inputs and 1 output. If enable is high and the analog input voltage drops below 1 volt, then we'll output a 500 millisecond active high pulse on reset out. Otherwise, reset out should stay low. Before we start designing, you need to know that there are a couple of different types of connections that you can make inside GreenPAK Designer. Here's a quick look at a completed design. Notice that there are green wires and orange wires. A green wire is a matrix connection. You may have heard about the GreenPAK connection matrix or seen that term in one of our data sheets. The connection matrix allows you to connect one block's output to another block's input. Behind the scenes, there is a mux for every matrix output that determines which matrix input is connected to that output. So for instance, if you have an AND gate whose inputs are connected to other blocks, rather than this being a direct connection, it actually passes through mux. If we take a closer look at that mux, you can see that every matrix mux multiplexes between all of the matrix inputs. When you make a green connection in the GreenPAK Designer, it stores that connection information in the GreenPAK's non-volatile memory. When the chip is powered on, the RAM is loaded from the NVM and used to select which matrix input should be passed to that matrix output. What about the orange wires? Orange wires indicate dedicated connections, which are made by altering the configuration of specific blocks. I'll show you how that's done in a minute. Let's switch back to our blank project and start designing. First, I know I'll need an analog comparator to monitor that analog voltage. The SLG 46110 has 2 analog comparators, and I'll select ACMP0. Notice that ACMP0 is grayed out. This is because it's not enabled or powered on yet. We can enable the ACMP by connecting a logical high to its power-up connector. You could use any matrix connection for this purpose, but in this case, we'll simply use VDD. Now that the ACMP is powered on, we can configure it by double-clicking on it and changing its properties in its Properties panel. We want its threshold to be 1 volt, so we can select it from this drop-down menu and click Apply. The Properties panel shows us that the ACMP has a dedicated connection to pin 3, so I'll locate pin 3 and configure it as an analog input-output. Notice that an orange connection has now appeared between pin 3 and ACMP0. If you're not sure how a block works, you can access the Help wizard in the top menu, or you can click on a block and click on the Info button. To find out what the connections are around a block, you can just hover over it with your mouse cursor. For the purposes of this design, I want to know when the output of ACMP0 goes low, so I need to grab an edge detector from the components list. This programmable delay block can be configured as an edge detector. So I want it to be a falling edge detector, so I'll select that from this drop-down and click Apply. I'll click Set Wire and connect it to the output of ACMP0. Now when ACMP0 goes low, the edge detect will output a short active high pulse. I want that edge detector to trigger a 500 millisecond active high one-shot pulse. To do that, I'll grab a resettable D flip-flop from the Components panel. Notice that this block can be configured either as a lookup table or as a D flip-flop. This is one of our combination function components. You can choose which function you want the block to perform in your project. I'll reconfigure this block as a D flip-flop and connect its clock line to the output of my edge detector. For now, I'll connect its D input to VDD and its output to pin 8. We also have combination function D flip-flops that are not resettable if you don't need that functionality. Now I need a block that will create my 500 millisecond pulse. So I'll come to the components panel and grab an 8-bit counter. Celago counter blocks have multiple nodes, and in this case I need a rising edge delay that is 500 milliseconds long. However, when I max out the counter data, my delay time is only 10 milliseconds long. This means I need to select a different clock source for the counter. By default, the counters in the SLG 46110 are connected to its internal 25 kHz oscillator. I'll change that so that the counter is connected to the RC oscillator over 64 and adjust my counter data. I want my 500 millisecond delay to reset the flip-flop. I can do this by inverting the output of the delay with this lookup table and connecting that to the in reset pin of the D flip-flop. I'll connect the output of the flip-flop to the delay in pin of the counter. So now, in theory, when the voltage at pin 3 drops below 1 volt, this edge detector will go high, which will clock VDD through this flip-flop. 500 milliseconds later, this counter will go high, and its signal will get inverted and be used to reset that flip-flop. The last thing I need to do now is set up my enable signal. Rather than connecting VDD to the input of the D flip-flop, I'll connect that to pin 2. Finally, I'll add some labels to my pins and blocks for documentation and clean up the design a little. Before we finish up, let's run the rules checker to see if we need to make any changes. So it looks like I left this block in the workspace, so I will reset it and hide it. And it looks like it also suggests that we connect the ACMP's power-up connection to POR rather than VDD. In the next video, I'll show you how to use the GreenPAK development board to test your design and program it to a chip. If you'd like to learn more about GreenPAK or any of Celago's other products, please visit us at www.celago.com.